Topics of our space journey, so to say, today are space research and space technology. So very wide topics. So therefore, in the space research, I'll focus on the solar system research and on the space weather research. And in space technology, I'll tell about the space mission, space instruments, and what new technology can provide to us. Space has always inspired me, but I'm not the only one. In this drawing, made over 100 years ago, you can see an artist's impression about how to go to space. Those manned spacecraft are really exotic, but maybe not so practical. But when we look at that drawing, we see how the ground-based technology has used in space. And actually, this is a modern trend, as we'll see at the end of my presentation. In this drawing, you can also see small planet, Mercury. And our dream to go to Mercury can become true, because last Saturday, European Space Agency's Bepi-Colombo mission was launched successfully from Kourou. Actually, it includes two spacecrafts, European Planetary Orbiter and Japanese Magnetospheric Orbiter. Those spacecraft includes instruments to measure particles, partly coming from the sun, partly coming from the planet, and also electromagnetic fields, and in such a way to make Mercury space weather research. We could ask that why to make space missions, why to make space research? In my mind, space is something which can change and which already has changed the way how we see the Earth, our place in the universe, and our possibilities. The Earth, in some sense, is floating in the space, as seen in this beautiful picture taken almost 50 years ago from December 1968 during Apollo 8 mission. But nowadays we need more than ever continuous global information about the state of our Earth in order to keep it livable. Space research relies on the space technology, and it makes us life possible and gives new technological inventions. A new space technology provides also us possibility to go to new places, to carry out space exploration. For example, go to the surface of a comet. Generally speaking, I could say that my research is something that I'm interested in to understand how the sun affects different worlds in the solar system. The sun is affecting the Earth and or other solar system bodies by the gravitation, sunlight, and the solar wind, continuous flow of the charged particles. Therefore, I could say that I'm interested to understand space weather at different objects. Some of them having a strong intrinsic magnetic field, like the Earth, some not. Some having a tenuous atmosphere, some a dense atmosphere. Some being small, low gravitation, but we have also large objects. But before we had a possibility to go to space and measure space, we had to test our hypotheses on ground in our laboratories. First by using mechanical devices, but then after our knowledge about electricity and technology in general, we could also build electrical devices. In this photo taken almost over 100 years ago, we see a famous Norwegian space physicist Christian Birkeland in his laboratory, working with his Terella, little Earth device. It was a vacuum chamber where a high voltage accelerated charged particle which generated aurora-like light around the magnetized ball, which modeled the Earth. In our group at the University of Aalto, we also have built our own Terella, which in our modern terminology, we could say that it's an electric space weather simulator. But nowadays in space physics laboratories, one of the most important devices are powerful computers, which gives us possibilities, so to say, go beyond the laboratory and to travel in time, in past and in the future with the help of computer simulations. Our group has also developed over 15 years Mercury space weather simulations for Bepi-Colombo mission to help instrument development, and finally when the data becomes available also to help data analysis. Here we see an example of our three-dimensional time-dependent Mercury simulation. We see that the near Mercury space is a really dynamic region. It will be interesting to see, can our instrument really observe those features? And or more maybe exciting, what new we can observe with our instruments. So we have made this kind of simulations for Venus, the Earth, the Moon, Mars, Saturnian Moon, Titan, comets, asteroids, in order to support our data analysis. So in our research, the basis has always been space instruments, our involvement in space instrument projects. If I would have give this presentation 2004, I would have told about our Aspera 3 instrument on Mars Express mission, and that our goal is to observe atmospheric erosion at Mars and to understand better the evolution of atmospheres of Earth-like planets, Venus, Earth and Mars, and why they are so different. If this presentation would have been a few years ago, I would have told about our Eka particle instrument on Rosetta comet mission. The research goal of the Rosetta mission was to understand better the formation and evolution of the solar system and what conditions for life it provided and is still providing. But now there is one instrument on the top of my mind, and it's Serena instrument on Bepi-Colombo mission. Serena instrument package includes actually 4 sensors to measure particles from the sun and coming from the planet in order to make space weather research. But if this presentation would be in 2022, then I would tell more about our PEP particle instrument on JUICE Jupiter mission. And I would tell that the instrument will investigate Jupiter and its moons, which form a kind of small solar system, and which investigate especially icy moons, which probably have a liquid water and subsurface oceans. So they are objects which are very interesting on the astrobiological point of view. Actually, we are now at the moment testing our PEP instrument, putting the first time all sensors together. And the goal is that we have a flight instrument ready next year, and the planned launch is 2022, so that we can make measurements in 2030 from 2033, and hopefully also a little bit longer. This means that when I'm talking about the PEP instrument, I'm talking about a quarter-century-long project. We could say that the JUICE mission and PEPI Colombo mission are old-school missions, which can make a really comprehensive measurements. But when the time from the starting of the project to the time when the first data comes is very long compared to the human's lifetime or the technology development time. But thanks to new technology, we can nowadays do many things which were impossible to do a couple of years ago. Our most latest example on this is Aalto University's Suomi 100 small satellite, so-called CUBE satellite, which will be launched less than 1 month from now from California, from SpaceX company's Falcon 9 launcher. Already our small, tiny satellite includes techniques and technologies that will change the space technology, space missions and space instruments, and therefore also later the space research. But I would like to end this our small space journey by going back to where we started, so to PEPI Colombo mission. But now jumping 7 years forward to the future. If I have a possibility to give a presentation in 2025 on the behalf of the whole instrument team, I hope that I could announce that PEPI Colombo, its Mercury and planetary orbiter are working well, and that our instrument has started its measurements. Then one space dream would have become true. Thank you very much.